Yes, it is started the recording. Professor Rajesh, you can start.
Yes,
please.
yeah. Is my screen visible?
Yes.
One second. I'm just... Yeah. Hi, everyone. So hope you are able to see my screen. So today I'm going to discuss on big data analytics. As we know everywhere, the term big data is a very huge and a massive data. So when we talk about big data, so first of all, we should know from where we are getting the data and who are the people deliberately, or who are the people raising the big data. So when you see here, the very first introduction slide that I am showing here is this particular big data is coming from the different ways, like an example, a social media, or let us take an example like, YouTube, or from the social networking sites, we have our Facebook, right? And also from Amazon, or from online shopping, or anywhere. If you see, even for the medical history, or even for considering an example like, playing games, online games. So these are all the ways where we have huge amount of data, which is growing every day enormously. And I have just shown an example here in terms of a table, which is like, like how our files used to be. So when we have our normal file, which is a Word file, where it will be in terms of only bytes, or even in terms of megabytes, only in MBs, KBs or MBs. But when you take the pictures, when you are taking with a very good mobile, very good resolution, so obviously the image quality is going to be much more high. And we want to upload that in the social networking websites. So considering an example, let us say if we are going to, let us say, India, okay, if we are all coming to India, then everyone wanted to see Taj Mahal, which is located in Agra. So when everyone is going to, see the Taj Mahal, and they wanted to take photos in front of Taj Mahal. So when they want to take photo in front of Taj Mahal, then again, they will be uploading that photo. And also what they will be doing, they will also upload in the social networking websites, whatever they have taken from their mobiles. So they will upload the photos, and at the same time, they will also upload the photos that they have taken, like selfies. So because of all these things, the data is being generated enormously in the social networking sites. Also, when you look at LinkedIn or any other platforms, I am not very sure like which kind of platform will be used in in the Turkey. Professor Adam, is it only Facebook or any other also?
Not only Facebook, all other social media networks are using in Turkey as well. And people are sharing their tweets, their messages on all social medias.
Okay, thank you. So when we are keep on sending the same messages again and again, then there is enough space is required by all the database management system people. So obviously they have to maintain lots and lots of data. That is one part. Now when we look at data which is being represented in three different typical tasks. One is structured data, another one is semi-structured data, and then unstructured data. So if the data is structured, then which will be very easy for us to process. And if it is semi-structured, yes, we can do a bit of analysis, and accordingly we can further take the data whatever we want. But when it is unstructured data, obviously it is very difficult, and where we need so many techniques, so many algorithms in order to process the data. So that is how the basic information that I would like to throw on what is big data. So the big data will be usually coming from the different sources, as I have told you, from maybe social networking sites, or maybe from even when you are playing, when you're watching football, or when you're watching cricket, or any particular game. So each and every second will be recorded, and thereby the particular amount of data, whatever is being recorded, that will be again stored, and again the people will be forwarding that, or applying some other techniques where they will be processing into some other context. So this is how the data will be tremendously, rigorously increasing in volumes. So that is where I'm going to show it to you. As I have mentioned here, structured, where the data will be completely analyzed, and which will be very easy for all of us, even for the novice users. It will be easy to capture the data. So like an example, like, Excel file or SQL, probably you might have gone through with the SQL language, right? Structured query language, where you will have different kind of attributes, and you will be able to design a table. Let us general examples, like employee data, employee table. So where you will have employee number, employee name, employee salary. So those are all the fields which you have, because everything is completely structured. Each and every attribute will be having a particular record, and thereby it is very easy for us to process the data. When you look at the other one, which is unstructured data, where you have all our social networking sites like Facebook, Twitter, Instagram, YouTube, all these are all the other platforms where some of the data will be structured and some part of the data is not structured. So it is very hard for us to apply the techniques and to get the unstructured data into structured format. And the last one, which is semi-structured. So when you see semi-structured, here you can see some of the like graphs, an example as graphs, or maybe online shopping. So here, these are all semi-structured. So where you can get the data with some simple techniques, with some simple measures or metrics, you can get the data. But whereas in unstructured data, this is the very toughest one. I cannot say that, it is completely hard, but with knowing some of the algorithms, then only you will be able to do. So like random forest, all machine learning algorithms, where in which you have to apply in order to get what the data you want. Now, the evolution of big data, when you talk about evolution, it has started with a very simple example, which I am pointing here, the telephone. So earlier, when we were using normal telephones, landline, then the data is being generated is very minimal, and also which is not stored. But when you take a mobile, where each and every person used to have a WhatsApp or Facebook, or they will be having so many other apps, and every time those data has to be recorded in somewhere or other databases. And coming to the other point, when you talk about desktop, from the desktop we have been migrated into clouds. I mean, I am telling you all the possible ways how the evolution has happened for the big data. And also when you see another example, like traffic, previously there was the cars or the vehicles, trucks, buses, and all that, they will not have any kind of tracking system. But now if you see, we used to have a tracking system for almost all the vehicles. So when you are maintaining the traffic tracking system, absolutely those data has to be stored somewhere or other in a different format. So when you are storing all this data, obviously you need huge amount of database. So when you wanted the huge amount of database, it is very clear that we need to maintain them. Okay, so that is the point which I wanted to focus here. Then another one is, if you can see IoT, when there are the devices which are connected into one another, then obviously the data increasing. The data will be increasing every year and then. Then another point is when you are buying some products in online. Let us say I wanted to buy a Samsung mobile. I want to buy a Samsung mobile where I can I am educated person and I know what are all the requirements that I want. Accordingly, I can immediately search by looking at the tabs. But when you see the people who doesn't have a basic knowledge on the mobile phones and all that, but still they will be able to search in the Amazon or any other online shopping website that you are using. So people will simply type mobile. So when they type mobile, they will be getting so many keywords. So when they get keywords from there also, and how those keywords are being generated, it is we, the users, are typing and searching the keywords. So when I am typing, let us say Samsung mobile or mobile with 4 GB RAM, mobile with 8 GB RAM, then accordingly for the next users, it is a benefit. In what way, you can ask? So the moment when I type, all these relevant keywords will be stored, and those keywords will be helpful for the next people. Like how you use in the when you wanted to search in the Google. Okay, when you're searching, let us say VIT one time, okay, immediately it will even show you some of the search keywords, VIT Vellore, VIT India, or even when you're looking for big data. So if you are searching for big data techniques, immediately you will be getting the relevant examples. So how are you getting? Because the point is, people are working with the n number of times they are repeating it, and thereby it is happening. So that is also one of the points which I wanted to highlight. Then another point is with respect to an example, big data, especially in the stock exchange. When you talk about stock exchange also, lots of people will be doing their trading. And when they are doing the different transactions, it is very clear that huge amount of data will be given. So when the huge amount of data is being generated every minute, different transactions they used to do that, then obviously so much of amount of data and so much of large volumes of data is required in order to store it. Then another one is with respect to healthcare. People used to maintain these days, I mean for the past 10 years, they used to maintain a very clearly smart healthcare system. So when you say smart healthcare system, so we need to know, I mean, if I'm not going with any sort of records, I will directly go with a particular number. If I have my number with me, then which is more sufficient, or if I have a card, simple card, which is having a barcode system, then directly I can go and get my details, and I need not to carry all my documents. So all the documents are being there in a particular repository, and which is a smart healthcare system. So when you are maintaining smart healthcare system, yes, it is good. But at the same time, when you are having multiple files, then the data is being generated enormously. And if it is only for a limited healthcare system, yes, limited patients, yeah. But if the patients are being generated, if the patients are using the data very much, in a high-ended, so obviously the data has to be, or the maintenance has to be given in a very sophisticated way. And the same thing will also applies for the transport, as I have told you. If you just compare some 20 years before, so there was no proper tracking system. And especially whenever you are, moving from one city to other city, probably you might be paying a toll. I don't know how it is in Turkey, but usually in India, we have a toll. So when you are moving from one city to another city, there will be a system where you have to scan. I mean, your vehicle number will be scanned by the machine automatically, and then you have to pay for it. So these are all smart transport. So when you are maintaining all these kind of smart transport system and all that, it is very much essential that which kind of data you are going to use. Are you using smart data? And in that smart data, are you working for structured or semi-structured or unstructured? So it is always better to go with semi-structured, so that you will be able to retrieve the data by minimal number of steps or by minimal number of algorithmic techniques. As I have told you, random forest, or even we can work with other machine learning techniques. Then, as I have mentioned, another point, Google search, where you will be having n number of repeated words. That is why I gave you a best example in order to understand, when you wanted to search a particular product online. Okay, when you wanted to search a particular product online, like an example, like mobile or any shoe, anything. So when you are searching for the first time, then only your keyword will be coming. But when you are searching for n number of times, the same keyword or the different keywords will be appearing. And also when you look at power grid, now the same way how I have told smart healthcare, smart transport system, now smart power grid also we have. So each and every minute, each and every second, the amount of electricity that is being used in the home as well as in the industries, in the educational sectors, everywhere, all those information will be recorded. So when all these information are being recorded, are stored, then obviously the data is increasing. So now we can see how the data is in what kind of fashions. I have quoted here totally 6 V's: volume, velocity, variety, veracity, and then value. So whoever we talk about big data, obviously we should know what are the V's that are associated with the big data. So the first one, if you can see here, which is V. So volumes of data. So too many volumes, as especially I have mentioned here, stock exchange, every day in each and every country, too much of volumes of data, too much of transactions will be happening. And then velocity, the speed, how fast the transactions are being executed. Okay. And the next one is variety. As I told you, 3 different types, basically structured, semi-structured, and then unstructured variety of data. Then veracity, which talks about accuracy and the quality. So how much accurate your data is, and what are the quality presentations that you are going to have with it. And finally, it lasts with value. So when you say value, it is with the economical data. So how much data you are going to have for your safety, and what kind of security techniques that you're going to apply. So these are the number of V's, the major 6 V's which are associated with the big data. Okay. I hope Professor Adam.
Yes.
Yeah, it is clear, right? I think it is working.
Yes, it is clear. It's a very good presentation.
Yeah.
If our participants have questions at the end of the meeting, we will have some questions from the participants, and our participants can note their question as well. Okay.
Yeah. Thank you. So coming to the next one, which is data analytics lifecycle. So it starts with a discovery, like how you are working with the other, probably you might be knowing software engineering lifecycle. So similar to that kind of fashion, we also have data analytics lifecycle. It is starting with discovery, then followed by data preparation, and then model planning, model building, communications, and operationalize. Now, the first one is when you are into collecting the requirements, like what kind of technique that you wanted to apply in order to get the end result. If you have unstructured data, what kind of technique that you have to apply? or if you have structured data, how you're going to process it. That is what I have shown you here in the structured data. What are all the process that can take place, like Excel and then Word and DB2. So all these things will be working under structured data. So that is how you have to plan. And these are all the steps which are associated with the data analytics lifecycle. So now another one is the challenges. What are the challenges of the big data, where people are not having a clear idea on the specific data, what they want? Considering an example, if any question is being given by a faculty or by a teacher, so you should not immediately start solving it. You should understand the logic behind the given problem, and thereby you will be able to solve it. So lack of understanding how to work with big data. So that is one of the major drawback which is happening even in the industries. Then the next one is poor data quality. If the data is not appropriate, then it is very, very hard to process it. As an example for this, so when there is a robbery or when there is some kind of incident happened, then if you wanted to identify who is that person, who is the I'm sorry, who is the person behind it, then your quality of the image should be very much appropriate, and then only you will be able to picturize, you will be able to formulate what are the scenes behind it. And the silos, yes, data silos means this is the one where data are being stored in a huge volumes. And the other one is big data issues in scaling. So there are two types of scalings are there. One is called horizontal scaling and then vertical scaling. So when you talk about this vertical scaling and horizontal scaling in big data, there are so many issues which will be raising. Especially when the people are not having idea on working with big data, it is very difficult to resolve those issues. Then what are the different varieties are there in the big data technologies? So these are all the so many challenges under big data, and also incorrect integration. If you wanted to integrate the data from one source to the other source, it is very hard. Then heavy expenses, yes, obviously, we are trying to use so many data items. When you are using so many data items, then you need to maintain the appropriate technologies in order to store them and also in order to retrieve them. Then next one is real data or real-time big data issues. As I have told, considering an example, like, when people are trying to post the same image, like visiting a place, like let us say, visiting India, as I have told you, Taj Mahal, or maybe visiting US and Liberty of Statue. So like that, if they are keep on uploading the photos or maybe videos again and again, even though if it is available, then it is very, very risky issues. After that, we need to verify what are the data items that are available. Then another one is where you can do a good projects. That is the slide which I am showing you here. In terms of research, if you wanted to work, like you can clearly work on discovering the consumer shopping habits. Now, already we have some of the implementations in Amazon. When you are buying a product, let us say you are buying a product which is with respect to shoes. You're buying a shoes. So the moment when you buy a shoe, automatically it will suggest you to also buy a pair of socks. If you're buying a table, it will also suggest you to buy a chair. So these are all some of the updations, predictions, which you have to consider in terms of big data analytics with respect to shopping, online shopping. And another one is personalized marketing, and also finding new consumer or new customer leads. So these are all the various ways where you can look at, and also predictive inventory ordering or real-time data in terms of security issues. So these are all the various ways where we have an opportunity to work on research problems, and also monitoring health, like linking with the smart healthcare, and also maybe linking with IoT. So how we will be able to make the system in a sophisticated way. So these are all the examples that work under big data analytics. And after the examples, then pretty sure what are the different analytics that we have. We have first one, descriptive analytics, and then we have diagnostic analysis, then predictive, and then prescriptive. So these are the four typical analytics that we have, or we can even say the first one, descriptive analysis, is nothing but wherein which you will be able to record. Okay, you will be able to record and takes place the descriptive items. And also when you look at the other one, which is with respect to diagnostic, so which means each and every item is going to be recorded, and after recording, again it will be further after descriptive, it will be further diagnosed. So when it is going to diagnose, then it is very clear to have a prediction system. And once the predictive system is done, then it is very clear to represent the prescriptive items. And then we have the different types of tools, starting with Hadoop, then which is mainly used and also to helps in storing the data, analyzing the data and all that. So that is how we have HDFS here. HDFS. So this HDFS is nothing but Hadoop distributed file system. So this Hadoop distributed file system is one of the key component in the entire big data architecture. So in this big data architecture, when you talk about this HDFS, this is especially used to maintain the files, huge amount of files. And thereby, it will be able to analyze the data. Then we also have other tools like MongoDB, which is used on the specific data sets, which are frequently changing. Then we also have Talent, and thereby we have Cassandra, Spark, Storm, and Kafka. So this Kafka is the one which is used for distributing environment. Wherever we have a distributing environment system, accordingly, it will be emphasizing along with fault tolerance system as well. Then next one we have here Cassandra. It is also works with distributed file system, but it will check the chunks of data. And Spark, which is a real-time processing tool, which is used for dynamic data, to handle the dynamic data. And the Storm is as an open source real-time computational systems, like when we talk about like Python, or when we talk about other programming languages, so where we can use this. And the applications, in terms of applications, if you see here, you have e-commerce. The first one, it talks about optimizing, because optimization is very much important in the big data context. So once you are able to optimize the resources, then it will be very clear to maintain the big data in a proper way. Otherwise, even if you have big data systems, but if you are not able to maintain, then it is very tough. Then coming to the next one, which is education and as well as marketing. So here we need to come up with the different courses in order to maintain the standards. After that, we have healthcare. So with respect to healthcare also, we need to look at the medical history of the different patients, and also, as I mentioned in the previous slide, smart healthcare system. So smart healthcare system is very much important to maintain that. And then we have here media and entertainment, banking sector, telecommunication, and government approaches. So with respect to the main one, which I was talking is HDFS, Hadoop Distributed File System. So where it is mainly meant for to store the data and also to analyze the data. And after that, we have, a different kind of components are there. So when I wanted to show you the different kind of components which are associated with respect to Hadoop ecosystem, I just wanted to show you that. So here you have, hope you are able to see the Hadoop ecosystem. These are all the different tools which are represented. It is starting with HDFS, okay, Hadoop distributed file system, and then we have MapReduce. So there are different kind of approaches are there in the MapReduce process. So after MapReduce, then we have different sections like Hive, Spark, and then these are all the other tools, Kafka, and then Pig, HBase. So these are all used for to reduce the content in a concrete way. It's not like random. A step-by-step procedure is being given in the MapReduce functionalities. And among HDFS and MapReduce, we can say MapReduce is the complete, like we can even say like heart of the Hadoop ecosystem. So if we don't have MapReduce, then it is very hard. Once MapReduce process is completed, then we have a resource manager, which is Yarn. So this is called as yet another resource. So this is for the navigation, and thereby we also have other working environment. So these are the basic things. So that is how when you especially talk about Hadoop environment, here you have components, the listed components. So starting with HDFS, MapReduce, Yarn, and common utilities. Are you able to see my screen?
Yes, we are listening you.
Yeah, thank you.
I think you completed your presentation, Professor.
I'm just, if they have any doubts, yes, they can ask me.
Yes, I want to ask participants if they have any question about the big data analytics and the big data analysis technologies. I can give permission who wants to ask question to the Professor Rajesh.
Yes, I have a question.
Yeah, please, Professor.
Okay, thank you so much. Thank you very much, Rajesh Kaluri, for this good and useful presentation. My question is our personal data safe in the big data space? If not, how can we make it safe?
In terms of security, you're asking, Professor?
Yeah.
So actually,
personal data.
Okay.
Safe in the big space, big data space.
Generally, when you see here our Hadoop system, in the Hadoop system itself, Hadoop ecosystem itself, we have in the Hadoop system or in the Hadoop core components, we have as by default security which is aligned, which is called Kerberos. So usually this Kerberos will try to maintain the personal data or whatever the data that we are storing in the HDFS. All these are being represented or maintained by one of the plugins or one of the technology called Kerberos.
Yeah. Okay. Then another one. Is there a relation between data mining and big data?
Sorry, Professor, again, please.
Is there a relation between data mining and big data?
Yes, Professor. Actually, if you see the data that we start with, DBMS, database management system, from there, that is the one of the prerequisite. So that is like the first one. And from that, we will go and work on data mining, where we use different set of machine learning algorithms. Even with the limited data, we will apply data mining, or even for the huge data, we used to apply data mining algorithm. So it is all about, finding what exactly you wanted.
Thank you, your answer.
Yeah.
Okay, thank you very much. I think there is another question.
Yes, please.
From our participants.
Yeah.
Thank you very much for your presentation. It was a very good and gorgeous presentation. And I think if you don't have any other message about the big data or another subject, we can conclude.
Yeah.
Okay. Thank you very much, Professor Rajesh, for your presentation. And we will meet in Bangladesh in January, I think, in a conference. So
Yes.
I hope, yes, take care. Tell my best wishes to your friends as well, to the Vellore Technical University, and take care. Bye-bye.
Thank you very much.
Yes, I hope to see you at the other times. Greetings to India, and say hello to your colleagues.
Thank you, Professor. And also, I invite you and other colleagues to come and visit VIT, and we can also have, we already have MOU. Gazi University and VIT are already having MOU. Then we can work on, adjunct professor, like some of your colleagues can come here, or maybe Adam, or maybe you, okay? Or maybe you can invite us, we can come and stay for, a semester and complete our courses.
Yes, already we are trying to invite you to Gazi University as well. But we have some preparation for this. We will apply for your, budget situations. So after, if we complete the diplomatic or other works, I hope we will do that.
Yes. Definitely, we will love to do those things.
Yes, already, we have a relation between VIT and Gazi University. We signed the agreement, from the international office. So all other listening participants can apply for this participation. If you want to go India, and if you want, they call any other colleagues. And some of participants are asking about Professor Rajesh. Some of participants,
please.
Yes, asking about sharing all the slides.
I can share.
Okay, thank you very much. If you share with me, I will.
Yes, I will email you. Definitely, I'll email you.
Okay, thank you very much.
Yeah. Okay.
Okay, bye-bye.
Thank you. Yeah, bye-bye.
Thank you very much.
Yeah, bye. I can leave the meeting now, right?
Yes, you can. Yes, you can.
Okay, thank you.
Okay, bye-bye.